What if I told you that the biggest solar storm in 20 years has just hit Earth? Despite the good fortune we've had in avoiding severe consequences this time, astronomers remain on high alert. This is because the most violent solar cycle in a long time is far from over. A massive sunspot has formed, reminiscent of the one that caused a major catastrophe in the USA 200 years ago. If this spot continues to grow, we could be facing some serious challenges. The storms that are yet to come may either treat us to breathtaking auroras or paralyze our communications and power grids within minutes. On May 11, 2024, Elon Musk shared his concerns. The SpaceX CEO posted an alarming graphic that illustrated the immense pressure the recent solar storm had exerted on his satellite system. A violent stream of particles from the sun had struck Musk's Starlink satellites, driving up their measured values for functionality and load. The satellite's protection mechanisms were stretched to their limits. An even more intense storm could potentially overwhelm or even destroy this technology. Such a scenario would be nightmarish, not only causing regional internet and mobile network failures on Earth but also turning dozens or hundreds of satellites into hazardous space junk. Musk's post underscored our narrow escape this time, but it also served as a warning. Starlink satellites are among the most advanced in the world, and this incident was a critical test of their resilience against solar storms. Solar storms are considered one of the underestimated dangers of the 21st century. Experts have long warned of a potentially civilization-testing storm. Streams of particles from the sun that strike Earth's magnetic field not only produce stunning auroras but also pose significant threats to our technological infrastructure. Auroras, the beautiful light displays typically visible near the polar regions, are caused by streams of electromagnetically charged particles from the sun. These particles are captured by Earth's magnetic field and trapped in magnetic deposits above the poles. Normally, the magnetic field prevents these particles from penetrating deeper into the atmosphere. However, at the poles, the particles move up and down until they lose their charge, creating the spectacular light shows known as auroras. The strongest solar storm in 20 years recently caused auroras to be visible much further south in the northern hemisphere and in parts of the southern hemisphere, displaying a stunning array of colors. Experts predict that exceptionally strong storms will continue for some time, allowing us to witness more of these beautiful displays, or face significant challenges. The most violent solar flares in 20 years can unleash gigantic streams of particles that reach Earth within 20 to 30 minutes, offering minimal preparation time. These streams, triggered by sunspots or coronal mass ejections, pose substantial risks. Sunspots are temporary dark areas on the sun's surface caused by strong magnetic activity which suppresses convection processes, leading to a drop in temperature and the formation of extreme forces. These forces can release large amounts of energy in a single burst, propelling myriads of particles into space. Currently, particular attention is focused on a sunspot group called AR3664. This group consists of 16 smaller sunspots forming a large cluster. In early May 2024, this spot was so large that it was visible from Earth with solar eclipse glasses. This sunspot, 15 times larger than Earth, was responsible for the intense solar storms that affected Starlink satellites. AR3664 has produced 75 M-class and 10 X-class flares in 1 week. M-class flares are medium strength, while X-class flares are the strongest. On May 3, 2024, an X1.6 flare was observed, followed by several more X-class flares, including an intense X4.5 flare. These eruptions release enormous amounts of particles that can reach Earth quickly and can cause larger coronal mass ejections. We are currently in a solar cycle that lasts about 11 years, and we are at the peak of solar activity. This cycle is marked by extreme and unpredictable fluctuations in solar activity. During the solar maximum, the most violent X-class flares are expected, along with the feared, one big storm. The current maximum, occurring earlier than expected, worries scientists and suggests something unusual is happening with the sun based on recent activity in AR3664. It is suspected that the sun's magnetic fields might be reversing, potentially leading to more frequent and intense geomagnetic storms. The last significant solar storms, known as the Halloween storms of 2003, reached G5 intensity and caused global disruptions to power supplies and satellite communications. Auroras were visible in unexpected regions such as Florida and Mexico. Forecasts for the coming weeks indicate that AR 3664 could send storms of similar intensity, necessitating preparedness. Although the sunspot is currently pointing away from Earth, providing temporary safety, it will soon rotate back towards Earth, possibly bringing another season of intense geomagnetic storms. The Carrington event of 1859, the strongest documented solar storm in modern history, serves as a stark reminder of the potential impact of such events. Named after British astronomer Richard Carrington, this event triggered spectacular auroras visible as far south as Cuba and Hawaii. In the USA, the Carrington event caused significant disruptions to the telegraph infrastructure, with telegraph poles sparking and igniting. In conclusion, while we have been fortunate so far, the ongoing solar activity underscores the need for vigilance and preparedness. As we monitor sunspot group AR 3664, it is crucial to understand the potential impact on our technological infrastructure and take steps to mitigate the risks. Whether through advancements in satellite protection or developing new technologies to withstand solar storms, humanity must be ready to face the challenges posed by the sun's powerful and unpredictable activity. Imagine looking up at the sky in the morning and seeing what appears to be a fire. This was the experience of many in the USA around 1859, during the strongest documented solar storm in modern history, known as the Carrington event. This event, named after British astronomer Richard Carrington, occurred from August 28 to September 2, 1859. On the morning of September 1, 1859, Carrington and his colleague Richard Hugson independently observed an unusually bright flash of white light on the sun's surface. This was likely the first time astronomers witnessed a solar flare. This solar flare was part of a massive sunspot region that triggered strong geomagnetic storm activity. The coronal mass ejection, CME, reached Earth within about 17.6 hours, due to its enormous speed and energy. People worldwide saw the effects of these extraordinary geomagnetic storms, which produced spectacular auroras visible in Europe, North America, and as far as Cuba and Hawaii. In the southern hemisphere, the southern lights shone as far south as Santiago, Chile, and Queensland, Australia. In the USA, the Carrington event caused significant disruptions to the telegraph infrastructure, the most advanced communication means at the time. Telegraph systems failed, sparks flew from telegraph wires, and the surrounding areas caught fire, leading to fires and damage to telegraph equipment. Many telegraph systems were destroyed, while others ran without any additional power supply, powered solely by the energy from the solar storm. The effects on the technology of 1859 were dramatic but minor compared to the risks to today's civilization. If a similar event occurred now, the consequences for our technologically dependent society would be catastrophic. Satellites, power grids, GPS systems, and communication infrastructures would be severely compromised, with estimated economic damage running into the trillions of dollars. The failure of navigation and control systems could cause major accidents and disasters, particularly in air traffic and shipping. The Carrington event illustrates that solar storms and CMEs are generally harmless to humans and nature but pose significant risks to our technology. Earth has likely experienced thousands of such violent storms. Solar storms occur frequently due to the intense magnetic activity on the sun's surface. These activities lead to solar flares and larger CMEs. A solar flare appears as a sudden bright eruption of energy on the sun, resulting from the release of magnetic energy in the sun's atmosphere. This energy, consisting of light and high-energy particles, can be released in a small burst within minutes or drift into space for hours. CMEs, on the other hand, eject large clouds of magnetized plasma. Normally, such ejections reach Earth within a few hours or days. In 1859, the CME's energy was so great that the plasma cloud reached Earth in less than 20 minutes, making it an exceptional event. Despite this rarity, we must expect such unusual streams of particles to hit us again at any time, which is concerning. Particle streams, while potentially dangerous, are actually beneficial. These streams, consisting of protons, electrons, and heavy ions, practically omnipresent. They contribute to space weather, carry energy through space, and help shape our climate. The continuous flow of charged particles from the sun's outer atmosphere forms the heliosphere, which envelops and protects the solar system from interstellar cosmic rays. Without these particles, we would be unprotected from intense cosmic radiation, and life would likely be impossible. To protect ourselves from the actions of these natural phenomena, we need to safeguard and improve our technologies. Modern satellites are built to be extra resistant to space storms and flares. Modern satellites and power grids are designed to remain resilient to strong electromagnetic fluctuations. However, this resilience only applies to a small proportion of satellites and power lines. Many networks and devices are still outdated and more likely to fail in a strong storm. Governments worldwide are concerned and are taking the threat seriously. Electricity companies constantly work on new technologies to protect their grids, substations, and power plants as much as possible. A prominent example of a storm that paralyzed an entire power supply is the geomagnetic storm of 1989. This storm hit the region in Canada particularly hard, paralyzing the entire power supply for a whole day. Satellites orbiting Earth are the most exposed to the Sun's high-energy particles, and the same applies to the International Space Station, ISS, and the spacecraft that supply it. These particles can damage electronic components and lead to serious malfunctions. In space, even minor accidents or failures can quickly become life-threatening, which is why figures like Elon Musk and NASA fear storms like these. In conclusion, the Carrington event of 1859 and subsequent geomagnetic storms illustrate the profound impact solar activity can have on Earth and its technological infrastructure. While we have made advancements in protecting our technology, the potential for catastrophic damage remains. As we continue to rely more heavily on technology, the importance of safeguarding our systems against solar storms becomes increasingly critical. Preparing for these events and improving our technology's resilience will be essential in mitigating the risks posed by future solar storms.